Vinegar, stain remover, gardening tool, and of course, flavouring. But did you know that vinegar is actually just ethanoic acid? And how do acids work? Let's take a look. Acids, when they're dissolved in water, release H plus ions. But then how are you supposed to differentiate your ethanoic acid from your hydrochloric acid? Or your wine from your phosphoric acid? This job fell to... Yeah, no, I'm not saying that. This gentleman here, who decided to call the new system pH, or potential of hydrogen. And the way he decided to work out pH was with this equation here. pH is equal to the negative log of the concentration of hydrogen ions. This meant two things. The first thing was, every pH value you went down, you increased the number of hydrogen ions by tenfold. It also meant the less hydrogen ions something had, the more basic it became. That is similar to bases. And there were many different ways of indicating pH until 1933, when a Japanese company created the universal indicator, which worked on a simple system that the more acidic something was, the closer to red it became, and the more basic something was, the closer to purple it became. And it was essentially just a mix of very famous indicators. And this meant on the other end of the spectrum, you had things like toothpaste, milk of magnesia, soap. And the pH value on these is high, that is more than 7. And a lot of you would have heard the term alkali used to describe them. And that is somewhat accurate, except the real term is bases. Alkali only applies to bases that are soluble in water. And then when two opposite values react, it creates salt and water. As the anion of the acid and the cation of the alkali react, as do the hydroxide and hydrogen ions. And now buckle up, because here comes the part that's past Year 7 science. A man named Hammett went, hang on, what if the pH scale isn't enough for all the acid I want to create? And so he creates his own mathematical function. So first we have to look at something called the dissociation constant. Now the dissociation constant is equal to the concentration of hydrogen ions multiplied by the concentration of anions over the concentration of the non-dissociated compound. And what you can do with this is sub it into the Hammett's function. So then you get the dissociation plus the log of the unprotonated base over the concentration of the protonated base. And that gives you Hammett's acidity function. This gave birth to something called superacids, including this one, which is fluoroantimonic acid, and something called magic acid, although it can't make coins disappear. This meant something like magic acid, rather than having a theoretical pH of about -10, could have its own value. And superacids are really helpful in multiple chemical processes, including alkylation. That brings us on to the last part of this video, meta-acids. Now you see this phosphoric acid? Dehydrate it, now you have something called meta-phosphoric acid. And obviously the double bonds to oxygen can only mean one thing, polymerization. And here you have polymetaphosphoric acid, and it can be used in glass production as a fluxing agent to lower melting points, chromatography, which creates more accurate results, and finally as a preserving agent in food. And just like that, we've come full circle, back to the start of the video. Thank you so much for joining me on this short video of acids. I know there's a lot more to cover, and I'd love to do it in another episode someday. Please like and subscribe, and feel free to join me next week where we'll be talking about batteries. Bye!